Paris watched an enormous iron skeleton rise skyward. Workers climbed higher without modern welding equipment available. Thousands of iron pieces needed perfect connections everywhere, yet nobody simply welded those pieces together then. Instead, workers used another technique requiring intense coordination. Hot rivets became the tower's permanent structural connections. Each connection had to fit precisely against neighboring pieces. A single mistake could disrupt an entire section. The higher construction climbed, the greater risks became. So, how did workers actually build this tower? Before we begin, tell us where you're watching from. Paris needed something spectacular for its upcoming exhibition. The 1889 World's Fair created enormous architectural expectations. Organizers wanted visitors immediately impressed by France's progress. Gustave Eiffel's company proposed an astonishing iron tower. Its planned height made the proposal especially controversial. Many Parisians questioned whether such construction could succeed. Some artists even considered the proposed structure offensive. Engineers faced a completely different question from critics. Could an enormous iron framework remain structurally stable? Their answer depended upon mathematics rather than appearance. Wind pressure became their greatest concern during planning. Tall, solid walls would catch tremendous atmospheric forces. An open framework offered a much smarter alternative. Air could pass through thousands of surrounding openings. That principle shaped the tower's distinctive curved profile. The structure gradually widened toward its enormous foundations. Higher sections became progressively lighter and narrower above. This geometry helped distribute forces throughout the framework. It also reduced unnecessary weight across upper sections. But successful engineering required much more than calculations. Workers needed thousands of components fitting together accurately. Those components could not simply be improvised on site. Instead, engineers prepared detailed drawings for every section. Each drawing specified dimensions, angles, holes, and connections. Factory workers followed those instructions during manufacturing operations. Large iron pieces were produced inside specialized workshops. Machines shaped plates according to carefully prepared measurements. Workers drilled connection holes before components left factories. That decision transformed construction into controlled industrial assembly. Pieces arrived carrying specific locations within tower framework. Nothing depended entirely upon guesswork during final erection. The approach resembled assembling an enormous mechanical structure. Each component already belonged somewhere within that system. That organization became crucial once construction moved upward. Workers would eventually handle pieces above crowded Paris streets. Mistakes there could create serious delays or hazards. The factory therefore solved problems before workers climbed. Even small inaccuracies could complicate later connections significantly. Engineers needed components matching their drawings consistently. The tower's success depended upon that hidden preparation. Yet another problem remained before assembly could begin. Workers needed a reliable method joining massive iron. Modern electric welding was not available then. Instead, 19th century builders relied heavily upon riveting. Rivets could create exceptionally strong permanent connections. But installing thousands required skilled workers working together. Each joint would demand timing, strength, and coordination. The tower therefore depended upon human teamwork extensively. Every workshop decision affected construction hundreds of feet above. The design was finished before construction truly started. Soon those drawings would become an enormous skeleton. The next challenge would be raising it skyward. Construction actually began inside workshops outside Paris. Workers transformed engineering drawings into enormous iron components. Each piece followed measurements established by Eiffel's engineers. Nothing was shaped randomly during this preparation stage. Machines cut plates according to carefully prepared dimensions. Other equipment drilled holes for future riveted connections. Workers checked each component before sending it onward. Incorrect pieces could disrupt several sections during assembly. Factory production therefore became part of structural engineering. The workshops operated like enormous mechanical construction sites. Teams handled cutting, drilling, shaping, and inspection duties. Each worker performed a specialized task during production. That division increased consistency across thousands of components. It also reduced confusion during later construction stages. Every finished component received identification before transportation. Those markings indicated its intended location within tower. Workers could then recognize pieces arriving at construction. This system prevented unnecessary searching among similar components. The tower contained thousands of individually manufactured iron pieces. Many components looked nearly identical from ordinary distances. Their differences became important during final structural assembly. A misplaced piece could complicate several nearby connections. Engineers therefore treated organization as seriously as strength. Before transportation, sections underwent additional fitting procedures. Workers assembled certain portions inside workshops beforehand carefully. This exposed potential problems before pieces reached Paris. Connections could be checked without dangerous elevated working conditions. Measurements were compared against original engineering drawings repeatedly. Any mismatch could then receive correction inside workshops. This preparation saved valuable time during tower construction. It also reduced uncertainty once assembly moved upward. Transportation presented another logistical challenge for workers. Large iron sections had to reach Paris safely. Some pieces were too large for ordinary handling. Special arrangements helped move them toward construction areas. Once delivered, workers organized components according to location. Construction therefore resembled assembling an enormous mechanical puzzle, but iron pieces still needed permanent structural connections. That responsibility belonged primarily to the riveters. Riveting required several workers performing separate actions. First, another worker heated each rivet until glowing. The heated fastener then traveled toward its connection. Timing mattered because hot iron cooled surprisingly quickly. One worker positioned the rivet through aligned holes. Another worker held the opposite side securely. Additional workers used heavy tools against the rivet. Repeated blows reshaped its exposed end permanently. The finished rivet locked both iron pieces together. Thousands of these connections gradually formed structural continuity. Each individual fastener appeared insignificant beside massive beams. Together those fasteners created an enormous connected framework. Riveting therefore became central to the tower's construction. It also demanded unusual teamwork among construction crews. Workers needed coordination rather than individual strength alone. The process became faster with experienced, specialized teams. Skilled riveters could maintain consistent working rhythms. Their efficiency mattered as construction climbed higher. At ground level, mistakes remained relatively manageable. Higher sections offered far less room for correction. Workers eventually needed to perform these operations skyward. That transition would introduce an entirely different challenge. The tower was no longer merely factory material. It was becoming a structure above Paris itself. Soon, every connection would happen under enormous heights. The tower's growing skeleton now reached above Paris. Workers faced their most demanding construction phase yet. Iron sections had to meet at exact locations. Thousands of holes needed complete alignment before riveting. Even slight movement could complicate those connections considerably. Temporary supports held major sections during assembly. Workers positioned beams before permanent fasteners were installed. Surveyors checked angles throughout each construction stage carefully. Their measurements guided workers working higher above ground. The process became increasingly complicated with increasing height. Riveting crews developed an efficient system for joining. One worker maintained a small forge nearby. Another heated rivets until they became bright orange. The heated fastener then traveled toward its destination. A worker quickly placed it through aligned holes. Another worker supported the opposite side with tools. Heavy hammer blows then reshaped the rivet's end. Cooling iron contracted tightly against the connected pieces. That contraction created strong permanent structural connections throughout. The entire process depended upon remarkable coordination. Workers needed precise timing during every riveting operation. A cooled rivet could no longer form correctly. Therefore, heated fasteners traveled between workers rapidly. Each member understood exactly when their task began. The system resembled an industrial performance above Paris. Heat, noise, movement, and height surrounded construction crews. Communication became essential whenever several teams worked nearby. Workers used gestures and shouted instructions across platforms. Experienced crews developed rhythms that increased production speed. Safety presented another challenge during elevated construction work. Platforms surrounded sections where workers performed their duties. Temporary structures provided access beside unfinished framework. Workers moved materials across narrow, elevated working areas. Tools required careful handling around people below. Loose objects could become dangerous when dropped downward. Construction supervisors therefore controlled movement throughout busy areas. The tower's 4 enormous legs created another challenge. Their positions had to remain correctly aligned throughout. Each leg followed a carefully calculated outward curve. As construction rose, those curves gradually moved inward. The 4 sections eventually approached one another above. Their alignment depended upon constant measurements and adjustments. Hydraulic equipment helped position enormous structural sections accurately. Workers could make small corrections during assembly. Those corrections prevented larger problems during later stages. The higher sections required increasingly careful logistical planning. Components became smaller as the tower narrowed upward. Access routes changed whenever new sections became complete. Workers constantly adapted their working positions accordingly. The construction site itself changed every day. New beams created fresh platforms and pathways above. Completed sections simultaneously reduced available working space. Below, Paris continued functioning around the construction site. Thousands watched the strange structure growing above them. Some visitors admired its unprecedented industrial appearance immediately. Others remained convinced the project looked dangerously ambitious, yet the framework continued rising according to schedule. The tower's height transformed ordinary construction into spectacle. Workers became tiny figures against the enormous framework. Riveting crews continued connecting piece after piece together. Their work slowly transformed scattered components into structure. No welding torch created those permanent connections there. Instead, thousands of rivets gradually locked everything together. The method was laborious but remarkably effective then. Soon the remaining work would reach unprecedented heights. The upper tower would test every construction method. The Eiffel Tower proved iron could redefine modern construction. Thousands of rivets replaced welding throughout its structure. Skilled workers transformed drawings into an enduring landmark. Their methods still reveal extraordinary 19th century engineering ingenuity. Subscribe for more forgotten construction stories from history.